Hello, this is our group project video. My name is Martin Trinidad, student ID 39621050.
Hi, my name is Paul John Evangelista. My student ID is 46237144.
Hi, my name is Mark Tullen. My ID number is 67686714, and this is our group project. We're currently assigned under the final groups as Cornell Collab. So if you grade accordingly, you can see our names. So to get started with the circuit, over here, most of the implementation is the same that you see in the FreeNove tutorial that we were asked to download. The only difference between this circuit and the ones that were online is with the relay aspect, which is right over here. As you can tell, we don't have a motor. Online, it asked for us to put a relay and a motor, and the motor would have simulated the sprinkler going on and off with the water irrigation. However, we did not have a 9-volt battery, so instead, in a more creative fashion, we decided to use the red LED over here that will turn on, and that's going to simulate the sprinkler going on, and when motion is detected, the sprinkler will turn off during the sensed motion. And to go start with the code, we're gonna go over here and go to the water system.py. In terms of the relay code, we have this irrigate function right over here. Essentially what it does is it gets the timer that we needed for how much time to allocate to the sprinkler in order to keep it on and get the desired amount of water to the supposed lawn that's mentioned in the rubric. And as you can see from the display, it'll show on the LCD how many seconds are left, as well as the fact that the sprinkler is on. And it will be interrupted when motion is detected, and it will say so on the LCD as well. And when motion is detected, the LED will turn off to simulate that the sprinkler is off, and afterwards we'll continue once the motion is gone.
Okay, so my name is Paul John Evangelista. I'm going to be explaining parts of the code and the functions that I created. For this code, we actually wanted to simulate much faster base time, so we actually changed our X value, which is represented now in seconds, which is going to be 20 seconds, but in the actual code, it will be represented over the course of an hour. But like I said, for this purpose of the code, we're just going to make it 20 seconds. Additionally, we have local temperatures, local humidity, and water lists, and what this is just list, so we can access this later in the code. So scrolling down, if you go ahead and go down after the irrigate function that Mark explained, first thing I created was the average temperature for the hour. So what it's going to do is, over the course of the hour, every single minute, we're going to calculate the average time. So we pull the average temperature for the minute, and then we store that into the value temperature, as well as the humidity. And we do that over the course of an hour for about 60 minutes. And then once that's calculated, we divide that by the respective time, and then we get the average temperature and humidity. Now, the second thing that we needed to implement was the loop. What this does is actually calculating the amount of, the ETO based on our local temperature and the CMIS temperature, as well as the humidity portion. The reason for that is because we want a more accurate reading on how much to actually irrigate for the board and for our code. So we put that stored into the equation, and then afterwards we stored the equation into ETO, because let's say the CMIS doesn't update over the course of like 2 hours. What we're gonna do is we'll add all the times that the irrigation system didn't turn on, and then we'll divide by the X amount of time that it didn't irrigate for. So that's why we have ETO calculated multiple times. Now the bulk of the code is actually in CMIS update, but my lab partner Martin Trinidad will actually explain the other parts of this for the first section. I'll just explain the parts that I coded. Right over here, we have the irrigate time and the water. So irrigate time is based on the ETO that we calculated based off the local CMIS or the local temperature and humidity, and also the CMIS polls. So we have the equation that we got from the lab document, but we'll notice that right over here we have 17. Now the reason for that is because in our PDF we were told that we can irrigate for about 1,020 gallons per hour, but we only needed it to irrigate. We wanted to get down to how many gallons you could irrigate per minute. So we do 1020 divided by 60, you get 17, and then when you put the 17 here, it'll give us the amount of gallons of irrigate per hour respective to our ETO. And then we're going to compare that to just the CMIS ETO that was pulled from the website, and then we'd be able to determine whether or not we created a more accurate function with our values in irrigate time versus the water, which was just pulled from the CMIS. And then right over here, we have the irrigate. We irrigate for that amount of time in terms of seconds, which is why it's times by 60. And then on the LCD, you'll see it later in the video, it will show whether or not we saved gallons, a certain amount of water, or we lost a certain amount of water based on our calculations. And then the last part of the code that I made was right over here. It's just more so for the LCD, and it also tells us the local, it switch offs every single minute, but like I said, for this code, it's going to do it every second. It's going to flip between the average temperature and humidity, and then as well as telling us whether or not we saved gallons, lost gallons, or we didn't irrigate at all, or whether or not there was no gallons saved or lost. So that's what this part of the code is.
Okay, this is us testing the code. So 20 seconds is representative of an hour, and I'm using the CMS date 6/11 just for testing purposes. Right now it's calculating the local averages. In real time, it would be in an hour, but this is just for the 20 seconds. After it's done calculating, which it should be done right now, it pulled from the CMS, and now the sprinkler is on. I'm gonna motion, and motion is detected, sprinkler is off, motion is gone. Sorry, I keep moving. Yeah, and now the sprinkler is back on. It is finished, and what it's showing you is the average temp, average humidity, and gallons lost. We're gonna breathe on the sensor. This is to change the humidity. Okay, and as you can see, there's a great shift. So the humidity is 71 in the past one, and now it's 81. And yeah, it did a small calculation, and then now it's displaying the new humidity. What I'm gonna do right now is show you that we are actually pulling from the CMIS, just to compare it. So this is the temperature from the CMIS 6.7, humidity 88, and this is the hour 7. Going here, again, we're using the 6/11 date. This is hour 7, this is 88, 6.7, and just verifying one more, the next hour is hour 8, so that's 70 and 81, and this is 70.3 and 81, following my cursor, 70.3. Yeah, and that's our code. Thank you so much.